All right, people, congrats on the day off tomorrow or today, whatever day you're watching this. As promised, we'll still have our test on Wednesday, assuming we have school on Wednesday. So I'm going to post 3 videos of me working the entire review worksheet. This is video 1, I'll do 1 through 8. Video number 2, I'll do 9 through 16. And video number 3, 17 through 24. And of course it'll all be nice and labeled so you can figure out where to go to find what you're looking for. Remember that Miss Murray is hosting a Zoom session on Tuesday at 10 a.m. and the link is posted a variety of places, so you can join her there if you still have questions. All right, let's get started. The entire the test is all no calculator, even though the review has a couple of questions that you could use the calculator on. Okay, function g is given by cosine. Which of the following describes g on the interval from 3 pi over 2 to 2 pi? Okay, so cosine, and you ought to be able to graph cosine that quickly and know that it goes from 0 to 2 pi, and that's what it looks like. So from 3 pi over 2 to 2 pi, that would be this section right here. So that is definitely increasing, and it is concave down. So answer choice C. Number 2, the function f is given by cosine theta again, so this same graph we were just looking at. And g is given by sine theta. Okay. Which of the following describes f and g on the interval from pi over 2 to pi? Okay, so pi over 2 to pi, and this one was cosine. Sine graph, try to graph it on roughly the same scale so they look, kind of matched up. Sine starts at 0, ends at 0, in the middle's at 0, and does this. And this time we're talking pi over 2 to pi. So that would be that area and that area. So this one's the sine, that one's the cosine. So from pi over 2 to pi, this one, they're both decreasing.
Cut it, Daddy.
So
cut it.
Both decreasing.
I can cut it, baby. Okay.
Number 3. That's one of my kids in the background. Hope you enjoyed that, wanting his pizza cut. Number 3. The graph of the function g is given in this xy plane, so that looks like a tangent. If g is the result of the multiplicative and additive transformations of the graph of tangent,
A lot. Okay.
what is the period?
Like that?
Okay, I don't even know that I needed to say all of that. The period is how often it starts over.
This one. This one.
So if there's a 0 at 0 and at pi over 4, then that means that distance is pi over 4. So that means the period is pi over 4. I could also measure asymptote to asymptote. That's a little bit trickier for this particular problem because it's going from negative pi over 8 to pi over 8, but that's still pi over 4. So the period is pi over 4. Just a reminder that the normal period for tangent is pi as opposed to sine and cosine normal period.
Here.
Number 4. In the xy plane, an angle theta in standard position has a measure of pi over 3. Which of the following is true? The slope of the terminal ray. Slope of the terminal ray. Okay, what do I got here? So pi over 3. There's pi over 3. Let's see. Slope is y over x. Slope is y over x. But what is also y over x is tangent. So, I don't know that we talked about that, but the tangent of theta is y over x, so that's actually the slope of that line is the tangent of that line. So the tangent of pi over 3, using our tangent 3 trick, is square root of 3. If you don't know the tangent 3 trick, and you want to sort of back up and do sine over cosine, that's fine as well. You're still going to end up with square root of 3. Answer D. Number 5. Which of the following describes the graph of the cotangent of x? Okay, I think before I start reading those answers, I probably just want to see a picture of cotangent. I think I remember that it does not start at 0, it starts at an asymptote, and its period is pi, so pi away there's another asymptote. And so that's one difference with tangent, is where it starts. It's also decreasing rather than increasing, so cotangent looks like that. Now, possibly I could have answered all those questions without a graph, but I think the graph's going to make it easier for me, because all the questions are about vertical asymptotes. So maybe before I even look at the answers, it looks like all the asymptotes are multiples of pi. Excuse me. Multiples of pi. So those two are out. Pi plus k pi, those would be multiples of pi. So C and D are looking good for asymptotes. Function is decreasing. Yes, that's right. Not increasing. Not increasing. So it's got to be answer choice D, because of the location of the asymptotes and because it's always decreasing. Number 6. Function f is defined by the secant graph. Which of the following describes the domain of f? Okay, domain, so that's the x values. Okay, and secant has asymptotes, so this is another way of asking this is where are the asymptotes? I don't really know secant well. Instead, I'm thinking cosine. So there's sort of two ways to go about this problem. And I guess I'll just do both of them, because I don't even know which way I'd prefer without having to do them both. One would be graph, and maybe just graph of cosine, and I'm looking for where cosine is 0, because then secant wouldn't exist. So it would be everything except wherever cosine is 0. Kind of an algebra approach is really the same question. Where is cosine equal to 0? And then secant would be undefined wherever cosine is 0. So I can kind of go in a formula approach, or I can go a graphing approach. Really, our unit was more about graphing, so I think I'm going to go graphing first, and I'm still going to do it the other way, and I guess make sure I get the same thing. So I'm going to graph cosine of 1/2 x minus pi over 2. Just a real rough graph, because all I really care about is where it's equal to 0, or where it's equal to midline, which I guess is the same question because there is no up and down adjustment. So amplitude is 1. That doesn't really matter for this. Vertical shift, I'm going out of order, but those are the two things that don't matter. The left and right things, the period would be 2 pi over b, so that would be 4 pi. And my phase shift would be right pi over 2. So I'm going to go right pi over 2. That'll be my starting point. Cosine starts at a max. 4 pi away from that would be at 9 pi over 2. Again, you got to be quick with your fractions to make this work well. So that'd be up there, because it starts over 4 pi away. Period equals 4 pi. In between there, let's see, in between 1 and 9 is 5, so that'd be 5 pi over 2. That'd be a minimum. In between those two, 3 pi over 2 and 7 pi over 2, it would be at 0, and that's what I'm really concerned with, because that's where the asymptotes for secant are. So there's my cosine graph. And again, the reason I did cosine is because that tells me where the secant has asymptotes. So I've got asymptotes at 3 pi over 2, and then it looks like every pi away. So 3 pi over 2 plus, no, that'd be 2 pi away from 3 to 7 would be 4 over 2. So those are 2 pi away. So that looks like answer choice D. So I think I'm going to roll with that. I'm going to go ahead and do it the other way just to make sure. Let's see. Cosine's equal to 0. Now I'm thinking unit circle. Cosine's equal to 0 at pi over 2. And every pi after that. So let's multiply through by 2. So x minus pi over 2 equals pi plus 2 pi k, which looks good. Watch out for your hand there. So it's still kind of matching. Let's add pi over 2 to both sides, and that would get me 3 pi over 2 plus 2 pi k. Again, that's finding out where cosine is 0, because where cosine is 0, secant doesn't exist, and if secant doesn't exist, that's a domain problem. So I got the same answer either way. I'm going with D. So I'm not really expecting you to work it both ways, but wanted you to be aware of both ways. Again, if you're good with your trig, then maybe the equation way is quicker, but most of this unit has been about graphing, so maybe that's a more familiar way. Again, either one, whichever you like better. Number 7. Function g is given by tangent of 2 pi theta. Which of the following statements about the graph of g in the plane is true? Okay, so vertical asymptotes. Vertical asymptotes. Okay, this is kind of like the last one. I can do this sort of equation-wise, or I can do it graphically. Again, equation's probably quicker if you're familiar enough with the unit circle to do it. Graphing fits a little more closely with what we've been doing this unit, so whichever way you think works best for you. Okay, period for tangent is 2 pi over b. Excuse me, it's pi over b. So pi over 2 pi would be 1/2. So let's see, and there's no other changes to that, so all the rest of the characteristics are the same. Tangent starts at 0, and then 1 period away, which in this case is 1/2, is my next 0, and another 1/2 would be my next 0, and so on. So that's at 1/2, and that's at 1. Those are my zeros. Halfway in between the zeros are the asymptotes. That's what we're looking for. And then there's the rough graph. Again, I'm maybe overkilling what exactly I need to do for this problem, but it's good review. So the vertical asymptotes. Okay, well there's one at 1/4, and then there's one at 3/4. So they're half away from each other. The first one's at 1/4, and they're half away from each other, so that would be answer choice B. Number 8. Alright, this looks like unit circle kind of things. The figure shows the terminal ray of angle theta, standard position, intersecting the circle at point P. The function g is given by sine of theta. It's like we're just also throwing all these letters in there to throw you off here. For the angle beta not shown, where beta is between theta and pi. Okay, so this is theta, this is pi. So beta's got to be in between here somewhere. Which of the following is true? G of beta. Well, G is sine, so I'm going to rewrite this. I think this will make it a little easier. Sine of beta is less than sine of theta. Sine of beta is greater than sine of theta. Or they're equal to each other. Or we don't know, we don't have enough information. Okay, well sine is the y-coordinate. So the y-coordinate of theta is that. So that height, that's the sine of theta. Beta is more than theta, less than pi. So beta is got to be over here in this area somewhere. So beta lands in between theta and pi. So it lands over there. It's not equal to, so that matters in terms of the equal to sign. So it's got to land in here somewhere, which means its y-coordinate is less than, so that represents sine of beta. So the beta y-coordinate is less than the theta y-coordinate, which means sine of beta would be less than sine of theta. Goodness. Get all your Greek letters in there. All right, I'm going to stop the video there, and again, you can check the other videos for the other problems.